But you have to, if you want to multiply it, you gotta make it. On 20?
So there's a homework. The library.
Multiply, you can add and subtract mixed numbers. Multiply mixed numbers. That's what
Yeah. No, I mean, you can do it No!
Yep. All right, guys. Let me try to catch up to you a little bit here. So just remember, when you're, big thing here, you only have to find an LCD when you are doing what? Good. Because multiplying and dividing, if you find an LCD, the whole thing with multiplying and dividing is reducing, really. You reduce as you go. LCD is the opposite of that. So they kind of, it doesn't really make sense. It doesn't really jive with what we want to do with multiplication and division. So this is all multiply and dividing. But the first thing I need to do with this, and I'll show you something I just showed somebody else. This really is 2 plus 3/8 times 1 plus 1/6. Sorry, there it is. I should do that for myself. You guys understand that? Because 2 and 3/8 means 2 plus 3/8. I would actually have to FOIL that thing, which we haven't even talked about yet. Some of you guys know what FOIL is. FOIL means you would multiply this, and multiply this, and multiply this, and multiply this. Through all that. Let me just rewrite it so there is no plus. So that's why I take each one of these and change it to a improper fraction. Cool. So to do that, 8 times 2, 16 plus 3.
19.
So I get 19 over 8 times 6 times 1, 6 plus 1. And nothing cancels here, right? Which in a way is kind of nice, because then you just multiply straight across, right? 20 times 7 is 140, so 19 times 7 must be 133. Is that right?
Yes.
Sweet. And 8 times 6, of course, 48. And you don't need to make that into a mixed number, but if you wanted to, it would be, I don't know, 2 and something? Yeah, so 48, if you want to make that into a mixed number, 48 goes into 133.
37 over 48. 2 and 37.
Yeah, so it goes in twice. That's 96. Right, so you get,
37,
what am I doing? Getting crazy. You get, yeah, I want to do that. Good job. So you get 7, 37, so you get 2 and 37 over 48. It'd be awesome if I could write. Now, it didn't say to leave it in either form, so you could just leave it like this if you wanted to. Or for the practice, you can make it into a mixed number. That's fine. So number 4, the same idea, except now I'm dividing. But the first step still, I've got a mixed number in there, so the first step is change this into an improper fraction. 3 times 2, 6 plus 1, 7. How do I divide fractions? Yeah, multiply by the reciprocal. And here, this is awesome. 7 kills 7. 3 goes into 3 once. It goes into 9 3 times. So I end up with 1 over 3. Be careful. I know somebody did this. I'm not picking on you, but I get this all the time. I get somebody tell me the answer is 3. But where is that 3? On the bottom. Yes. Be careful about that. I see that a lot. You guys with me so far? No? Okay. Yeah. All right. Number 6. Same idea, really. Change it into a mixed improper fraction, 15 17 times 7 8/7. So it's a lot like number 2. There's nothing to reduce. So just got to multiply across. What is that, 136?
435.
435, yeah. Okay, cool.
So you can't change that to
Oh, you could. Yeah, so if you want to change this, 35 goes into 136. Let's see. 4 would be too much. Yeah, 3 times. Cool. Let's see, 5, 105, 31. So 3 and 31 35ths.
Yes.
Cool. Sorry, all that happened off the page. Number 8. What do you do first? Good. Change this. So 3 times 2, 6 plus 2 is 8 thirds. Divided by 1/5 times 5. Good. 5 over 1 if you want. Again, nothing cancels. 40 over 3. Jeff. And then if you want to, 3 goes into 40. 13 times because it goes into 39, so it's got 1 left over. So either one of those is fine. Maybe your 3 is more legible. That'd be awesome. Okay. It's hard to be less legible than me. Now here we got addition and subtraction. Now here's where we got to worry about getting like denominators. We might have to worry about borrowing, right?
it's addition.
Yeah, this is a nice addition. I don't have to worry about borrowing. That's cool. What's the LCD going to be here?
12.
12. So if I change this, let me see how I can write this. 8 2/3 plus 4 1/4. How do I make this into 12ths?
Multiply that 4.
Multiply by 4. So it'll be 8 8/12. What do I multiply this by? 3. 4 3/12. And now you add 8 and 4 is 12. 8 and 3 is 11. 11/12. How are we doing so far? Is that? Yay! All right. That is a good sound. I like that sound. All right. I'm being constrained by my. Okay. Now we got subtraction. Okay, so we might have to worry about borrowing. Doesn't look like we will. What's the LCD going to be?
20.
20. So I'll multiply this by 4. So we got 8 and 12/20. Multiply this by 5. 2 and 5/20. Thank God this is big enough to handle him. So 8 minus 2, 6. 12 minus 5, 7/20. Done. That side. All right. Mission accomplished. Number 14. So again, the same idea. I got room to play with here, so let me put it over here. 18 3/5 minus 17 5/6. So of course the first step is common denominator. If you want to, you can change these to improper fractions. This one wouldn't be horrible for that, but it really is good to get used to this borrowing and stuff like that. What's the LCD going to be? 30. So multiply him by 6 and him by 5. Cool. So we got 18 and 18/30 minus 17 and 25/30. What row? And of course now that's not big enough to handle that guy. So I borrow a 1 from him. So I add 1, and what's 1? 30 over 30. So then it becomes 17 and 48/30 minus 17 and 25/30. Now don't freak out. 17 minus 17, so I got no whole part left. The whole part goes away. 48 minus 25, 23, 30. So that's it. Woohoo! Okay. 16 is an addition. That's nice. What's the LCD going to be here?
9.
9. Even smaller, right? Because 9 has 3 in it. So 9 can be the LCD. So I multiply this guy by 3. 6 and 6/9 plus 3 and 1/9. Yeah, 9 and 7/9. Sweet. And it's funny, this book, 18, is the easiest problem so far, right?
You don't have to do any steps.
I love this book. It's awesome. So, yeah, I've already got LCD. This guy's big enough. Everything's set up for me. So 9 minus 8 is 1. 3/5 minus 1/5. 2/5. Please, Jeff, do those, all of those. No. So here, it's really just a plug and chug. What's the base?
2 1/2.
Yeah, that's the base, 2 1/2. And the height?
3/8.
3/8. So now I just have to do 1/2 times, what do I have to do with him?
Improper fraction.
Good. 2 times 2 is 4 plus 1 is 5. Nothing reduces anywhere.
Like straight across.
So I get 15 over
32.
32. And just to be careful, square centimeters. Oh. How are we doing there? Actually, that's section 4.7. Once you change it into improper fraction, it's sort of a review of the earlier sections. That's really the only new step. Okay. So, let's do some new stuff.
Oh, man.
Stay.
Change is bad.
Okay.
Change is bad.
I'll do that every now and again when I was teaching this to see who watched that show. So we understand that? You understand? Incline? Whoever laughed. My back first. All right.
It was like your con reference at the beginning of class.
Yeah. Cool. All right, so the last section we're doing in 4 is the last section 4.8. Just to remind you guys, we did skip 4.6. That was not a mistake. It's just not part of this semester's offerings. So you'll get that next semester. 4.8 is nothing really new. We're still solving equations. And I kind of warned you about this before, that we're going to learn fractions, then we do equations with fractions. We learn decimals, we do equations with decimals. It's basically that way throughout all of math. You learn something, you do equations with that thing in it. You learn something, you do equations with that thing in it. So, the simplest type of this to show you would be something like x This is what you hope for when I say an equation with fractions in it. And that is what you never hope for, ever. So how do I solve that?
U minus 3.
Yeah. So it's if it was x plus 3 equals 5, I would subtract 3. X plus something equals something else, I subtract. I don't care what they are. So I've said this before, the process doesn't care what's in there. I try to get the x by itself, I get the numbers on the other side. I don't care what those numbers are, fractions, decimals. So I'm going to subtract 3/4. And I've made an exceptionally nice problem because those already have LCD, right? So the first way to make these kind of problems harder is to have two fractions here that don't have an LCD. Ooh, so just give them LCDs and you go from there. Not a big deal, right? So here this is not too bad, 5/4 minus 3/4. 2/4, and technically I take points off. Good, you gotta make it, reduce that bad boy 1/2. Won't take off a lot of points, but if you don't reduce at the end, I'm gonna have to take off something. Take it off, be careful. So to make this a little more interesting, we would do something like this. So now it's a little more difficult, or a little bit different. And I'm going to show you something that works in general. There are several different ways to do this problem. I'm going to go, you could subtract the 1/4 and go from there, but let me show you something that works more generally. The worst part of this equation is the fact that what? What's the thing that makes this equation worse than it could be? It has fractions. More specifically, it has the stupid 4s on the bottom, right? The really cool thing here is this is an equation. I can do stuff to both sides. If it was not an equation, I would have to just live with it here. I can't just multiply and kill my fraction. I've got to just live with the freaking fractions. If it's an equation, I'm trying to make a big point of that, notice. Because the minute I show you that you can kill fractions somewhere, you guys kill them everywhere. You become fraction exterminator. You die. But why is it I'm allowed? How could I kill a fraction? What does this really mean? What's the operation for? What's division? So how do I kill it? Multiply. So I can multiply. I would multiply each side by 4. But really, if I multiply this side by 4, I got to distribute. So what I normally tell you guys to make it easier to see is I multiply each piece by 4. Does that make sense? If I multiply both sides by 4, I have to distribute, so I multiply each piece by 4. Right, now, why are we doing that? Because that will kill my fraction. That kicks ass. But if that wasn't there, I could not do that. Cool? It's just because it's an equation. I have two sides. I'm allowed to do something, and I'm good. So I can kill my fraction. So sure enough, die. So I get x plus 1 equals... Right, that's dead. So the 1's left alive, right? Equals 3. Now, I do sometimes get like that. What mistake did somebody make? They thought the 4 was... No, the 4 died. He's dead. So it's just a 3 there. And now that is awesome. What do you do? Subtract the 1. X is 2. Sweet.
Awesome.
So, of course, to make that problem more difficult would actually be the same idea as this one. Just make non-like denominators.
But then you find a common denominator
and then do the same thing we just did.
Yeah.
Yes.
So the 4, you chose the 4 because that's the denominator. What if you have a fraction that's different denominator?
I love it. So in general, I choose the LCD. If they're all 4s, then the LCD is 4. Sweet. So it's the same process. If it's different numbers on the bottom, it's the same process. Multiply by the LCD. So, purple's doing pretty good. Example, if I had, not you. You can do it, Jeff. Cool? Or you know, not cool. You don't have to agree to that. But you guys see what's going on? Now again, I kind of want to stay away from this a little bit right now. You could add this over there, you know, get the x's by themselves. There's nothing wrong with that, really. And I'll come back to that here in a minute, actually. But I want to focus on this because it's more generally helpful to understand this process here. So there's two main ways to do this. And I want to show you first the easier way to do this. And then I might not even show you the other way to do it. It always depends.
But you can make everything 15 on the
Yeah,
bottom.
the easier way to do this is to just make everybody have the LCD first. And then it's a problem just like this. So maybe I'll just stick with that. I won't even show you the other way. We'll stick with it. I'll show you the other way. All right, yes, ma'am. Sorry. Yeah.
Shows both.
Oh, you show me the other way. All right, yes. So what is the LCD going to be here?
15.
15. So what do I have to multiply him by? 3. 5.
Nothing.
I like it. Cool. So then I get 6x over 15 minus 5 over 15 equals,
7 over 15.
and then I multiply by 15. So really the cool thing is what happens is those just go away because of the fact that I'm multiplying by 15. Die.
I'm gonna say that every time I do it.
I like it. I want you to keep doing that in your next class, whoever your teacher is. Maybe like calling counselor, I have a student. I'm a little worried. Just say you had me and they're like, okay. So here, what's left alive? 6x minus 5 equals 7. I did not make this happen. This is going to come out nice. But sometimes you'll get fractional answers. Do not freak. Obviously, we're in the realm of fractions now, so you could get fractional answers. This will come out nice. Add 5. Divide by 6. I like it. Sweet.
So what's the other one?
So the other way to do that problem and the reason why I kind of want to show you the other way, even though I just said I really didn't, I want to show you because the math is really the same. It's just that one way makes more sense than the other to some people, or some other people like the other way. So it's good to kind of pick which way you want to do it. So that way seems really super cool. Cool. Stick with it. This is not really that different. This way is find the LCD and immediately multiply by it. Don't change anything. And you'll see why some people won't like this way, because you have to be a little more careful. It's a little bit quicker, but you have to be a little more careful. So LCD here, of course, is 15, and then just immediately multiply by 15. Now, and I want to show you the similarities between these two. When I multiply by 15, what happens here?
Reduce.
Good. 5 goes into 15.
3.
3 times. See that 3? So they're both the same. It's just one way is doing something before the other way did. You know, here 3 goes into 15. 5 times here, the 15's canceled completely, right? So I end up with 6x minus 5, and the same thing. That's just like a little bit quicker, because you don't waste time, making the LCD. You actually kind of do 2 steps in one. So whichever way you want to do it, doesn't bother me. Same things. I'm not going to keep going. All right.
You can also just, another way to say that is you multiply the top by what's missing to make the LCD.
Exactly. So that's the ultimate shortcut. Because the way I personally do these problems is to go from here directly to here. Because you're missing a 3, so it's 6x. You're missing a 5, so you're 5. You're missing nothing, so you're just 7. That's when you get more comfortable with this. You can start skipping steps. Yeah?
Can we do like a random question of 4.8? Can we do like number 5, for example?
Sure, yeah. Number 5 is, it's like the easier problem that's got a little more stuff in it. I say it's easier because notice all the fractions already have the same denominators. But it's harder because it's got more stuff going on. So it's, So again, you don't care that there's fractions. You just care that these are numbers and these are letters. You want your letters on one side, your numbers on the other side. So what's not supposed to be here? the 1/5, and 3x minus 2x is x. I can add the 1/5. So 1/5 plus 1/5 plus 2/5,
4/5.
and you're done. So see how the process doesn't change. The process says get your x's on one side, get your numbers on the other side. That process never changes. It's just that when I have fractions, I have to worry about like denominators and so forth, but the process doesn't care. And you can still check this like always. Now checking these problems starts to get a little bit more disgusting, right? You've got to throw these fractions into something that already has its own fractions and so forth, but you can check it just like always. Okay, so let me show you this. I've been sort of staying away from this for a little bit, but if I have this, does anybody know something about that kind of problem? It's got fractions in it. So let's attack it like we were before. What's the LCD? 35. So I want to do this the long way, and then there's a shortcut. And the shortcut people try to use way too often everywhere. Again, this happens all the time. So what if I multiply this? What is he missing? Let's say that one. 7. And what's he missing? 5. And then these can go away. Is that cool? So so you see how effectively the 7 just went up there? You see that? And effectively the 5 just went over there? Is that cool? So that's the shortcut then. The shortcut for this, I know some of you guys know this, is cross multiplication. But then you cross multiply everywhere. Again, the minute you learn something, you want to apply it like in all these, especially when you kind of like it. And cross multiplying kind of feels good for some reason. It's like, bam, oh, it's sweet. And there's no more fractions. It's quick. So then you're like, well, why don't I just do that kind of thing here? Yeah, let me make that 28 and 15. No, you multiply straight across, right? So the minute I show you cross multiplying, don't do it everywhere. It only works directly when you have one fraction equals one fraction. That's it. You could use it other places if you're clever enough and you understand how to adjust things, but that's the only place you can use it directly. So if I do that, I get 7 times 4x, 28x, 5 times 3.
15.
And here's like I was saying earlier, you don't let the numbers tell you what to do. You know what you have to do to make x by itself. What do you have to do? Divide. Right? This is 28 times x. So I divide by 28. I don't divide by 15. I don't do subtract 28. I know I've got to divide by 28 to kill it, so then the other side just gets it. Right? And it's a fraction. Why do I not care? Because I'm done. So one of the best places to get a fraction is at the very end. So you don't have to do anything with it. Okay. That's pretty much all I got. So everybody got a practice test, right? I'm going to bring, I just realized, I did put a couple, but not really. Next time we'll do more of these equations with fractions in it, because I don't have a lot of those on here.